Okay, welcome everyone. Welcome to this lecture on data structures in Motoko. Today we will talk about 4 topics. So the first one is shareable types and non-shareable types. This is a pretty confusing topic. When I started learning Motoko, I was very confused with this. So I'll try to debunk that. After that, we'll talk about variable, mutable array and non-mutable arrays, because that was also a pretty confusing topic. After that, we'll talk about TrieMap, HashMap, and we will use those data structures to create a simple CRUD application. If you don't know what is a CRUD application, it's an application where you can create, read, update, and delete data. It's the very basic and very important application. Most of the applications that we built are using CRUD functionalities. And we will finish the talk by talking about stable and non-stable data structures. I've already touched upon that in a mentorship session, but essentially it's related to the data being persisted with upgrade or not. So stable data will be persisted across upgrades. If you upgrade your canister, you will still see your data. Non-stable data structures, they are always reset when you upgrade a canister. Okay, let's go. So the first topic is this one, shareable types and non-shareable types. And so what are shareable types? I will show you an example of something that you cannot do in Motoko. So let's say I want to list my goals. So this is the goals for my DAO maybe. And for that, I'm creating a buffer. So I have to import the buffer library. Actually, this is like this. This is not correct. Yeah. So I'm specifying the type here, but you could also just do this. Oops. You could do without it. And then I will create a function to add a goal. I return nothing, goals.add. We've already seen that yesterday. And then I will show my goals. And so I just want to return the goals, like I just want to return that. So we've said that it's a type buffer. So this is async buffer text. Yep. Let's go and try to deploy that. Ah, oops. Ah, okay. This is really annoying. Okay. Fix deploy. I have just this simple, I have just this simple structure. So I have a README and a dfx.json. My canister is called my canister. So I will just deploy my canister. And I have an error. As you can see, I have an error. Okay, this is not the error I was expecting. Failed to load dfx configuration. Maybe I haven't saved this one, because there is a dfx. Okay. Yeah, this is good now. Okay, so what is the error that we are facing? It seems that we have a lot of text. Type error, shared function as non-shared return type buffer, and then it describes the buffer type, so we can see all the functions that we have on buffer. Type buffer, again, all the functions is or contains non-shared type text. Arrow unit. So the buffer type is a non-shared type. Why is that? Because the buffer type is a class and is also a mutable type. So let's say I have a buffer and I send it to another canister. Like, you have to imagine that when we send the data structures, it's like we are sending them out there in the world. And so it could be received by a user, it could be received by another canister, it could be received by anyone. And then this person would be able to call any of this function on our data structure. So the person would be able to do buffer.add at any point, just like we are doing here, but just we don't really know when and why this person would do that. So if this data structure was shareable in the sense that we could send it outside of our canister, we would run into a lot of issues. You have to imagine like you send that to multiple canisters and then everyone just add elements to the buffer whenever they want. It would be impossible for you to track and to understand how and when things are happening. So this is why in Motoko and even on the IC in general, it's not like specific to Motoko, it's all canisters on the internet computer, they cannot share some types. And so everything that is mutable, like a variable that is mutable, is non-shareable, a class is non-shareable, and all sorts of objects like this. For example, a variable like this is non-shareable, variable message, because you wouldn't be able to know who is modifying it when. So if you try, you will actually see that this is not completely true because you can do something like this. But Motoko is smart enough to understand that basically what you want to return is the value of the message, not the actual variable that you would send. So what it's going to do in this case, it's just going to evaluate the value of message and send the value back. But it doesn't understand it when you are using a buffer or any other non-shareable type. So that brings me to the second topic, which is array and mutable array. So in Motoko, we have two types of array. The first one would be the normal array that we've seen. The second one would be a mutable array. So this one, you would have to write it like this. I believe that's, yeah. So I can remove that. Those are the array. This one is the array if you are using other languages like Python, JavaScript. This is the array you are used to, because with this one, you can do something like this. You could do like message of type text and index of type not. And you could just, you could just reassign like a message var dot index will be equal to the new message. So in many languages, we are used to just looking at the index of an array and then modifying the value inside and just doing that normally and then returning. This is possible in Motoko if you have a variable inside the array, but for this one, it wouldn't be possible. So add message to add message var. I will call this add message var. I hope it's clear enough. And then add message to the normal array. You will see that it doesn't work. It says expected mutable assignment targets. And so this is not mutable because this is just text. It's not variable text. And so which one do you think we can share and which one we cannot share? Can we share this one? And can we share this one? Both. yeah, we should messages is shareable. We can only share messages. Yeah, messages is shareable, but messages variable is not shareable. So we can do a test. I will comment that out. So let's see this one. Return messages. This seems to work. And this one, shared function as non-shared return type var text is or contain non-shared type var text. So var text is a non-shareable type, and so we cannot share it. There is a work around that. There is a way to, still manage to use variables array if you run into a situation like this in the array library. So, oops, here. Where is my, yep. There is a function called freeze. Freeze transform a mutable array into an immutable array. So we could do this, return array.freeze. Our array is containing text, so we need to replace this with text, and then it would be like this and like this. And we would need to import array. So there is a good question in the chat, which is variable text an alias to the buffer type? No, because the buffer type is really a class, but I'm pretty sure that the buffer uses variable array behind the hood. If we take a look, Motoko base library GitHub. So this is the repository that contains the base library. If we go to source, we can see all the base library like modules. So those are the one, like when I'm importing array or buffer, I'm just importing those files actually. So array.mo and buffer.mo is here. And you can see that it's defined as a module. Then public class buffer. So it's more than just an alias because there is actually some, it's a class. So there are some variables, there are some methods and everything. But let's see. I'm pretty sure that it's using, this is here. So it's using a variable array to store the elements. And the array is growing or shrinking depending on how much elements we have in the buffer. And this is taken care for us automatically. So good question. Can one only use? Yes, that's why buffer is unshareable, because it uses mutable array, but also because it's a class and any class is non-shareable. Can one only use variable just in front of mutable variables? Not in front. I'm not sure I understand the question, Zender, if you want to specify. So that's about it for the mutable array. And if you want to learn more about the difference between the mutable array and the immutable array, there is, this document, which is a bit hard to read, but now that I've given the basis of the explanation, I think you should be able to understand it. It talks about mutable state, and it says that actor in Motoko can use, but they can never directly share their internal states, internal mutable states. Mutable data is kept private, so that's what we've said, is never shared remotely. In which case do we use var instead of let? I mean, it depends on your application. It depends on your use case. Like, I mean, if you have internal data, you don't want to share it. You can use variables. Most of the time, as we will see later, so we will talk about TrieMap and HashMap now. You will see that you will try to avoid any kind of variable, and I will show you why. So let's do a CRUD application. And for that, we will use a HashMap. What is a HashMap? Well, it's a class. A HashMap provides a data structure where you can store keys and associate them with values. And so you can see that the type of the key is specified as K and the type of the values as V. You can also read what is happening behind the hood, so what kind of data structures is used to generate the HashMap, but we won't dive into that today because today we'll just use the HashMap. So first thing first, import the HashMap. And so one question I always get is, what is the best data structure in Motoko? And just like in any other language, there is no answer to that question. It's about your use case and what do you want to optimize for? Do you want to optimize for search? Do you want to optimize for insertion? Do you want to optimize for efficiency of efficiency of search or insertion or removal? Depends on what your data structure is being used for. Another point to take into account is what is the use case? And in this case, we are storing messages, but we don't have any information about who is adding the messages. Like if some user add a message to my array, like for example, this one, I don't know who is this user and I cannot link back that to the user. What we want to do with the CRUD application is we want to use the map to create authenticated database. So let map is equal HashMap. So we are importing the HashMap class from the HashMap library, same as buffer. And we will link principal. This is the first time we are seeing principal. I'll explain what it is. And text. And we'll call that map of messages. Then to initialize a hash map, we need 3 parameters. The first one is the initial capacity. The second one is a equal function on the keys. So we need to find a way for those keys to be like a function that tests the equality of the keys and a function that hash the keys. So initial capacity, I will set it to 0. In any case, it will grow automatically. Then principal.equal and principal.hash are 2 functions from the principal library. So I'm importing it here. We can take a look. Principal.hash takes a principal and returns a hash. And principals.equal takes 2 principal and return a Boolean indicating if the principals are equal. A principal is an identifier for any entity that interacts with the internet computer. So a canister has a canister ID, and a canister ID is a principal. A user has a principal ID, and a principal ID is a principal ID, of course. So I've already shown you this, DFX identity get principal. This is my DFX identity. If you go on the Motoko Bootcamp dashboard, you will also see your identity on the dashboard. And keep in mind that your identity is not with internet identity. You have a different identity for every application. So I will explain why. This is my principal ID on the dashboard. So this is another one. And you will probably have another one for you. So a principal is just an identifier for every user. And we can use that to link messages and user together. And actually, maybe I will create a custom type. So maybe type post, which will be, we'll store the author of the post. So with the principal, the messages of type text, the title of type text, and time posted, which is the time where the post was created. And for that, I will use the time. So I'm importing the time type from the time library, and I can show you the time library. Time library is a library with only one function, which is time.now, and time.now returns the type, the time at the moment. It's in nanoseconds since 1970, so this is Unix type, Unix time, sorry. And the type time is just an alias for the int type. And instead of storing just text, I will store posts for each user. So each user has only one post. Public function create a post, and then post of type post, and async results dot results. Okay, so I'm importing a new type now, which is the type result. And so result is from the result library again. The type result is a type, so it's an alias type, and we haven't seen alias type so far, but alias type, sorry, it's a variant type. We haven't seen variant type, but variant types are just types with several options. And this one has only two options. It's either OK or error. And then each type can have a subtype. So let me show you. Public type results, public type creates post results is equal to results dot result of unit type or text. So what am I doing here? I'm just creating an alias to have a nicer type. And what it means is that if we are returning OK, then the type of our OK is unit type. So we are just returning the unit type. If we are returning an error, then we will also add a message for this error. Let me show you what I want to do. So what I want to do is add a post. Maybe post was not a so good idea. Maybe user is better. Like I just want to name of the user, age of the user, and time registration maybe. Sorry for the confusion, but yeah, I think post didn't really make sense because we can have multiple posts for users. So add create user. And so we will need to add this syntax. So shared, and then open parenthesis, open the brackets, caller. This is how you access the identity of the person calling this function. This is a principal. So this is our identity that we want to use for the HashMap. And this function creates a user profile if there is not already one for the caller principal. What I will do is switch map, and I need to rename that map of users dot get caller. And so I'm using a function from the HashMap library. So HashMap.get. HashMap.get returns the value associated with the key if present and return null otherwise. So we are doing a switch case, which is very important in Motoko. Switch case enables us to have two cases. The first case will be the case where the user is not found, so we will be able to add it. The other case will be there is already a user, so like this. So this one, no user registered yet for that identity. Already one user. So if we already have one user, it's pretty easy what we want to do. We want to return an error like this, and you have already registered. If there is no user, we want to do map users.put. And so put is insert the value with the key. So our key is our color. This is the identity. This is a principal again. And the value is a user, the user that is here. And then we can return OK, because we have successfully added our user into the database. And remember, we don't have any message for OK. It's just a unit type, so we just return the unit type. Here we have a text because we are returning an error of type text. And this is correct. Now I could add another function, which would be public function get user. With a specific principal, I will actually return results. Let me create a custom type. So public type get user results. If we are returning a user in the case of OK, and in the case of error, we will just be returning an error message. So get user results. And this function will return the user for the given principal. If not, returns an error message. And so switch again, map users.get. This time we are not using the color, we are just using the principal given as an argument. Case. So if we don't have anyone, we will return an error. Return error, there is no user for the given principal. Oops, sorry. And I can even return this principal as a text. So principal to text of P, that will be good. Case user, we will return OK, and we will return the user. And I need to add this. Okay, let's try. So we will deploy our canister to the playground and try to play with it. I've seen that there are a few questions in the chat, so I'll take time to answer that after the demonstration. Okay, so we have our canister deployed. Maybe I can add one method which would be useful, which is public shared color function who am I. This returns a principal, and I just want to see return color. I want to see what is the identity of the person calling. Because we don't know actually when we are using the Candid UI what kind of identity we are using. So we need to have some information about that. Okay, so apparently that's good. Let's see, who am I? Should return my principal. And so you will see this principal, it's the anonymous principal. So there is a anonymous identity, which is always the same, like everywhere on the IC. I can also show you. If we use dfx, we have this list of identity. So I'm using seb right now, but if I switch to use anonymous, dfx identity, get principal, you can see this is exactly the same and as the one I have here. This is because when you use the Candid UI, we are not login. We could login. So we could use this. For example, I could use my existing internet identity. Oops. And I hope this will work. No, this. I cannot. Why is it? It's so strange. It's very strange. Anyway. Yeah, we are not logging. We could log in, but we are not logging right now. So if I add a message, so this is here, I will create a user, let's say, and time of registration, I will need Unix time, nanosecond now. I don't think this is nanosecond. Whatever, this is not a problem.